In the last video, we determined what the linear equation of a graph was. We determined the slope, and then we determined the y-intercept. We're going to look at those same exact example problems and identify what x points are or y points are given a y point or x point. So let's take a look at our first example problem. This was the first example problem we looked at in the last video. We solved for an equation of y equals negative x. And this is our table here. So we have three component problems. And so for first, they're asking us to determine what's y when x is equals 2. Well, for an equation like this, all we need to do is plug it in. All right, so we got y is equal to negative, and plug in x equals 2. So in this case, it'll be negative 2. And we can look at our graph to see how straight of a line I was able to draw. So at x equals 2, right there, y is equal to negative 2. So that checks out. Now we're given a y value of 3, and they want to know what x is equal to. So this would be 3 is equal to negative x. I put a subscript 2 just to identify which one I'm looking at. And I can move the negative sign across. So x2 is equal to negative 3. So at y equals 3, I'm right here, x is equal to negative 3. That's consistent. At x equals negative 4, I plug in here, negative 4, that gives me positive 4. And I can check at x equals negative 4, I'm right here. That's a y value of positive 4. Great. So some of these graphs, you'll see that I do a better or worse job at drawing a straight line. And so we'll see how that affects the table, but the equations are exactly accurate, so we can follow those. Here is problem 2. Here we have the equation y equals 2/3 x minus 4. First, they want to know what x is when y is equal to 0. So I can say y is equal to 0 equals 2/3, and this is my first problem, so I'll call this x1 minus 4. And then I'll solve for x1. So I'll move 4 over to the right side by adding 4 on both sides of the equation. And then I'll multiply 3 halves on both sides. So I get 4 times 3 halves is equal to x1. So this is equal to 6. So we can check at x equals, or sorry, at y equals 0, that's along the x-axis. The x-axis crosses the line at x equals 6. So that's correct. Next, we have x equals negative 3. So at plug in negative 3, we get y 2 is equal to 2/3 times negative 3 minus 4. We get, let's see, negative 2 minus 4, that's negative 6. So let's check. At x equals negative 3, drop down, that's about negative 6. Doesn't perfectly line up, so you can see that I didn't draw this line perfectly straight. For point 2, or sorry, y3, we have y value of 2 right there, and they want to know what x is. So I can work out the problem here. So 2 is equal to 2/3 x3 minus 4. Add 4 on both sides, I get 6 is equal to 2/3 x3, multiply by 3 halves on both sides. This gives me 9. If I look at my graph at y is equal to 2, it looks like the way I drew it, x equals 10. But that definitely just means that my line is drawn just a tad crooked, right? So you can see the importance of drawing straight lines. So this is the third problem in the series where we're given this linear graph, and we were able to solve for the equation y equals negative 3x plus 3. Now for this problem, we're given an x1 value of 10 and asked to solve for y1. So let's start there. So if x1 is equal to 10, I could just plug it in directly here. I won't be able to see on this graph, as we can see here, it's going to be all the way down somewhere here that's not shown on this graph. So we should do it all by hand, but that's pretty straightforward, I think. So we'll say y1, which is the y value here, is equal to negative 3 times x1, which is given to us as 10, plus the y-intercept 3. This is negative 30 plus 3. This is negative 27. Yeah, so negative 27 is off the grid here, but we know that we can just plug in a value for x and find what our corresponding y value is. All right, next they give us a y2 value of 0 and ask to solve for x2. So we just need to plug in back into the same equation. So y2 is equal to 0. This is equal to negative 3 times x2 plus 3. You either can identify it here, or we can move the 3 on the other side to the other side. Negative 3 is equal to negative 3x2. Divide by negative 3 on both sides of the equation. You get x2 is equal to 1, positive 1. And for this one, we're within the scope of the negative 10 to 10 range for both x and y. So we can check at at y equals 0. So along the x-axis, the line crosses at x equals 1. So that's consistent. And then finally, we have x3 is equal to negative 1. And so we just plug it into this equation again. So we get y3 is equal to negative 3 times negative 1 plus 3. Negative 3 times negative 1 is 3. So y3 is equal to 6. This is also within the scope of this graph, so we can check x3 is equal to negative 1. So that's right here along this vertical axis. What is y? We predict that it's equal to 6. So if we follow that line, that's what our graph shows. Right? So you can see a pattern. We're just plugging in either for x value or y value, and then we can check along a graph to see if we match. Let's take a look at problem number 4. Problem 4, our given linear equation is y equals 1/3 x plus 4. First, they give us y1 of 0. So again, we just plug it in here. So y1 equals 0 times 1/3 x1, which we're solving for, plus 4. Move the 4 to the left of the equation. Negative 4 equals 1/3 times x1. Multiply by 3 on both sides, we get negative 4 times 3 is equal to x1, or x1 equals negative 12. So at y equals 0, so along the x-axis, this line will cross at an x value of negative 12. So it's going to continue beyond this point. Okay? And we can't see it, so we know it's around that area, just looking at the graph. Then we have x2 is equal to negative 3. We can plug in to identify what y2 is. So we got y2 is equal to 1/3 the slope times x2, which is negative 3, plus the y-intercept, which is 4. Negative 3 divided by 3 gives us negative 1, plus 4, this gives us 3. y2 is equal to 3. And now we can check again. x2 is negative 3. That's right here. This corresponds to a y value of 3. So that matches up. And then finally, y3 is given to us as 6. The slope is 1/3 times x3. Right? This is what we're trying to solve for. Plus the y-intercept 4. So I move the 4 over to the left side of the equation. I get 6 minus 4 equals 2. Equals 1/3 x3. Then multiply both sides by 3. So 2 times 3 is x3, or x3 is 6. And then we can check when y is equal to 6, you're up here, your x value is also 6. So that matches. Okay, so we're going to do one final example problem. This is the example problem where y is equal to negative 2x minus 6. So again, we have x1 of 8. We'll plug it in. At this point, I hope that you are able to observe the pattern. And why don't you pause the video and make sure that you can match the solutions that we're going to come up with. Okay, so for x1 equals 8, I get y1 that I'm solving for is equal to negative 2. That's the slope times x1, which is 8, minus 6, which is the y-intercept. This gives me negative 16 minus 6. This is what? Negative 22. So for x equals 8, we're off the charts. So we're definitely beyond negative 10. We can't visualize it with this graph, but I can use an online graphing calculator or my handheld graphing calculator to verify. Next, I have y equals 0. Remember, y equals 0 represents the x-axis, so we're going to be able to verify using the graph, but let's do it using the equation. At y equals 0 for y2, we get 0 is equal to negative 2 times x2, which we're solving for, minus 6. Move the 6 to the left of the equation. Then divide by negative 2 on both sides. We get x2 equals negative 3. And we can check this, right? So where the line intersects the x-axis, we see that it's at x equals negative 3. Right? And finally, we can check, we can solve for y3 given x3 of negative 8. So we go y3 is equal to the slope, negative 2, times x3, which is negative 8, plus the y-intercept, negative 6. So negative 2 times negative 8 gives us 16, minus 6 is equal to 10. This one we can check as well. So at x equals negative 8, we're right here, go all the way to the top, that's equivalent to y equals 10. So you can see that once we have the graph or the linear equation, we can solve for any corresponding x or y value because we have everything we need to know about the linear equation.